say that we have Z-score standards, we say that if we have Z-score standard, what that means is I have a normal event, like normal distribution or normal, let me say, normal data is usually should be inverted bell curve. That's what inverted bell shape or inverted bell shape that we have it. And here's the mean. Usually it should be here. And we will say that mean, for example, as the next part. And we will have a mu for a population and are those who are they have less than 30 students, which will say we have a sum. Now, if we have a community more than 30 students, or that it should go, we say that this is a population, and we have to use the new instead of this next part. And also we have S as a standard deviation. For example, and we have sigma for the standard deviation for the population. Here's that we have for population, and this is for what? This is for sum. Now we get the mean. We say that here is also the center of the population. Here we have x bar. We have to measure the x bar for the mean, mu, and there is another one which is called median and mode. And here's all it should be like this shape. If we have as exactly perfect normal distribution, they should be in the same line. And we say that for example, here's the 68%. The 68% of the data should range between. Should have a range between 1 mean plus how much? We should have a range of 1 mean plus 1 standard deviation as the maximum limit, and 1 mean minus standard deviation as the minimum limit. So we have the limit for the range that our data, 68% of the data lies in this range. It will be between mean plus sigma and mean minus sigma. And we have a normal distribution like this. This is called a normal distribution. If I want to have a more, or to check the more normality of the data, I should go and I should find another percentage which is called this area. The area. But by the way, the 68% will be known the area under the curve. And also we have, if I want another range is that we have this range and we have this range. This is what we call mu plus 2 sigma, and this is called mu minus 2 sigma. So there is another one. There is another range that we have. It's called mean plus 2 times the variation. Standard deviation that we have as a maximum limit, and as a minimum limit of that range we have mu minus 2 sigma. And here the area under this curve again will be about it will be about the red one. Is the red one. So the area under this curve, the red one, it denotes about 92%. So whenever you have a 68% of the data relate in this region, and we have this 92% of the data lie in the next region, which is minus 2 plus 2. And the third region we have mu plus 2 sigma. This is mu minus 2 sigma. The last region is that we have the third, which is 99%. 99% of the data will lie plus 3 sigma and mu minus 3 sigma. This is called the standard score, standard Z score. Z score, it means the Z distribution. And how can I do, and how can I analyze the data for finding whether we are on the same graph or not? We should check. First of all, I should find the X bar for the data, and then after that, I should find its standard deviation. Then after that, I will check the Z that I got, because this is the data, and the data should be divided. I will just divide all the data by this terms, X bar and sigma, get a standard normal distribution Z square, which is its area under the curve of the Z standard will equal to 1. So we have one normal distribution, it's called Z distribution, and its range between, here is the Z, it will be between minus infinity to infinity, and the area under the whole curve is equal to 1. This is what we are going to say that it's the Z square, the Z score of the distribution. Now, suppose that we have a data, so for this data we should find the X bar, and then we should find the standard deviation. I will check with the Z, and then I should compare the existence of that Z square, and I want to check with the area, and the area is, I think, here's in this table, this table will give you the Z and the values of N. By the way, that's not so. We said that we have the Z, this is called table Z. It's ranged between minus 3.4 to 0. This is one side. So the one side is like this. We have the Z, 0. We have minus 3.4. We have 3.4. And we have the range of the data. And here is the Z that I have. So here, the value of Z. The value of the Z, it should be here. And all what you see in the table are, by the way, here is Z. The table issued here Z value. For example, for the first one, we have 3.4. Let me see, here we have digits. The digits that will come after number 4. For example, if I have 3.45, so I should go to the first row, and I will skip 0, 1, 2, well, this is 0.40. Now this is 0.41, 42, 43, 45. So I should look after this one, and then I will find, for example, for 3.05, 3.45, you can see we have 4.0003. What that means? That means what area is there is the area. This area, the area under the curve for Z, here Z, when Z is less than 3.4, it will equal 0.003. Here is all the areas. All the area under that curve from minus 3.4 to the end, it will give you 0.003. For example, if I want to check for 0, how much is the area that we have to the left side of this curve when you have Z equal to 0? So we should go to the, here's the 0. For the 0 range, here here is 0, so 0.0, it means I am here. The z value is equal to 0.00. So what we have, the area under this curve, it will give you area is equal to 0.5. So 0.5. It means that the whole area of whole the curve, it will give you 1 unit. 1 unit is 1 unit square, and this 1 unit square maybe give you this is will show as could be as a probability, or it could be another thing that we have. Now, today we have, besides the score, so this was the score is to get the position of the data in a specific range. Now we have today interquartile range. Interquartile range, we need to know how much is that. Sometimes we have outliers. Outliers means that we have data out of the range. They are extremely high, or maybe they are extremely low. So these will affect on the normality of the data that we have. So we have to exclude them. We have to exclude all the data that we are in the high range. So how to find which data are outliers? We have a procedure to do that. First of all, we have to find a term which is called IQR. IQR is the interquartile range. Interquartile range, it means you will it means that you will sort the data and you will make them in 4 quarters. I will make the data and I will do them, sort them as 4 quarters. To do that, I need after that, I should find the range, which is Q3 minus Q4, and then add 1.5 of this percentage to the lower range, and add 1.5 of that one to the upper range. Then I will have the normal range, the range of the data, and what points that lies in above that range or lower that range is called outlier. Then how to do that? For example, for this example, I want to see where is the outliers in the data that we have. How can I know which of these data, 5, 6, 12, 13, 12, 15, which of them are outliers? Means that I should exclude them from my data or not. By the way, when you are just saying that you are going to
I non sto sostenendo.
A me se la outlier تاني outlier ثاني يعني شاذ شاذ يعني كتير يوم إذا لم يزداد شاذ لازم يعني أسامة من جامعة من الشاذ outlier ويتمنى شاذ يعني جايبه زمان زوجي outlier يعني زوج التمام ده زوج outlier بعد outlier أني كده أنا كتير كده من تمام درين بس شون درين procedure guys are now I have these data 5, 6, 12, 13, 15, 18, 20. I want to know which of them are outliers. First of all, I have to find their Q1, Q2. First of all, I want to know how much is the Q1 and the Q2. What is the Q? Q represents quartile. So all the data that we have The old data we can say that one of the data is Q1, Q2, Q3, Q4. I can say that the whole data can be divided into 4 equal parts. This is, I can do it in 4 ways. So I will name this one as the first quartile as Q1, Q2 is the second quartile, Q3 is the third, and Q4 is the fourth quartile. So what I should divide these data in 4 parts. First of all, how to do that? First of all, you have to arrange from minimum to maximum. Sorry. So we have 5, 6, 12, 13, 15, 18, 20. So we have 5, 6, 12, 13, 15, 18, 20. Now, how much is the number of the data? Or how much is n? 1, 2, 3, 4, 5, 6, 7. I have 7. So 7 divided by 4, because I want to know how much is. How much? 3.5 by 4. It's 2 point, 1 point?
1.20. 75.
Yeah. So 1.75. The mid one or the median is going to represent this one. So I can say this is the first one, and this is the second one, this is the third one, and this is the fourth part. You got the 2, 4, 6, 8. It's not 7. 5, 6, 12, 13, 15, 18, 22, 50. Now, 1, 2, 3, 4. Now, this is can be quarter 1. This is quarter 1. This is called quarter 2. This is quarter 3. This is quarter 4. Now I have the data. 8 data. It means 8 divided by 4 is I have every 2 data will represent a quarter. Now, this is the quarter, and I want to know how much is the value of the quarter 1. We got this one. This is quarter 1. Quarter 2, quarter 3, quarter 4. Now, quarter 3 is equal to 20. Quarter 3 is equal to 20. This is the midterm or the median that we have it. And look at this one. Quarter 1 is equal to 9. Look at this one. This value is equal to 6 plus 12 divided by 2 is equal to 18 divided by 2 is equal to 9. So I will name this one as a Q1. Quarter 3 is equal to 20. Where's the 20? Here's the quarter 3. 18, quarter 3. This is the value of interquartile. So look at the ID interquartile range. This is the quarter. The inter means the interface between the 2 quarters. So the interface between quarter 1 and quarter 2 is called IQR, IQR1, IQR1, which is I can say Q1. This is between quarter 3 and quarter 4. So I will take the upper and the lower, and I will take the average of them. So it is equal to 18 plus 22 divided by 2, which means how much?
40
divided by 2,
20.
10. Now I have these 2 values in the quartiles of the Q1 and in the quartile of Q3. Now remember that we are now going to find the extreme values. The extreme value. So Q1 now is equal to 9. Q3, the interquartile, 10. Now the procedure is saying that you have to add, make the difference between them. The difference between them means Q3 minus Q1 is equal to T minus 9 is equal to 11. Right? So I want to have 1.5 of this value. So 1.5 of the Q3 minus Q1 will equal to 1.5 times 11. Right? Which is equal to how much? 15, which is equal to 5, 6, 16.5. This should be added to the so now the range is the range. Here is equal to 9 and here is equal to 20. So I will go back 9 minus 1.5 of that Q3 minus Q1. How much is 1.5? It's 16.5, right? So 1.5, this is 1.5 of Q3 minus Q1. So I will go to the lower limit. I will say 9 minus 16.5 will give you how much? Minus how much?
7.5.
9 minus 6.5. 16.5, sorry. It's minus 7.5. Now I have the new data, new range, and here we have 20 plus 1.5 of that Q3 minus Q1. How much is that 20? 36.5. 20 plus 16.5, it means 13.6.5. So now the new range, this is the new range that we have. What is above that range? It will go outlier. Yes.
Why this way is positive 16.5?
So we have we have a range. Now I have start and I have the end. I want to know how much is the extended range. The extended range I should make the lower minus and the upper up. So I will increase that range by 1.5, the Q3 minus Q1. Now, the range is that we have minus 7.5 as a lower limit, and the plus is 36.5 as an upper limit. Is there any data outside this range, outside this range? Then it will be outliers. Then you should exclude them. It should be not normal to have such a data. For example, if you do a survey for a land and you have the data, it should look like such kind. When we have a data, look at outlier in the data, and you see that this outlier is not, you are concerned with the value of the data, so you have to exclude that data. How to know how much is, which one you should exclude them? You should exclude them by doing the IQR and then find the outlier. Sometimes also we have the data when we are doing the experiment in the lab. We have for a number of high data, we don't know, we might have a mistake in doing the experiment or having an error in the readings, because they are not in the range. So how can I know, or how can I pull them out? You have to find the IQR of the data and exclude them from the. How we do this? 1.5. It is in the range. 1.5. This is from the definition of having. This is a definition. So the definition is saying that you have to find the IQ and then multiply it by 1.5. And then this interquartile range will be added to the first one. One should be excluded from the first one, is that minus, and will be added to the extreme one to find the range. Okay, here's the steps that I did my calculations. Okay, so we say that we have a standard score. How to find the standard score? It's by using the Z table and the Z distribution. And the procedure to find the Z data for any data, first of all, you have to find its mean or its the average. Then after that, we have to find its standard deviation, which is the here is the S. And then after that, I go on to find the related value to that Z. For example, in this question, a student scored 65 out of calculus. So he got in calculus 65. Now, in calculus, we have he got 65 out of 100. Now, and he is in a class, and in this class, we have students taking, in average, they have about 50. So, the X that we have, it belongs to that student's mark. Now, for whole class, for the whole class that we have in the class, we have the students are more, in average, they took 50%. They took 50. And yes, there is some of them are taking higher values, some are taking less. And this is what give you a standard deviation. And how much is the standard deviation that we have? We have sigma or S equal to 10. Now, also, this is for the class. Also, she took or she scored 13 on history test and mean. This is belongs to calculus. For history, in history, she took 13. So she has 30. But in history test, we have students all students that we have in the class, in average, they took about mean, they took about 25. So in general, those class in history, they have taken 25. We have a variation with a test of a mean of 25 and a standard deviation of 5. Now, standard deviation is 5. Look at the two classes. Since here's her class in history, and here's her class in calculus. So can I say she was very good in calculus while she was not very good in history? Can I say? I cannot say directly this way. I should compare both of them. And I cannot compare between two samples. This is a sample, this is a sample. I cannot go and compare between the marks, because here we have the average of the class is 50, while here's the average of the class is 30. So there is a difference. Maybe we have the number of the students here is different than this way. So if that 65% in relative to the calculus is very good, than 30 that we have in history, which is only we have 25 average. So to compare that, I'm going to find the Z score for each of them, and based on that Z score, I will decide whether which one is good or which one is best. Now, for the one that we have, the x that we have here is 65 minus the 50. This is why 50, because I want to know how much is the z-score for the calculus. So for the calculus, Z is equal to the 65, the grade of the student, and what we have for the class, because we say that Z is equal to x minus x bar over mu. So x phi, she took 65 out of all the data, which is the range of 50, divided by the sample standard deviation, which is 10. Now it's equal to 15 over 10, which is equal to 1.5. So it looked like she took 1.5 out of what we don't know. We are, this is a z-score. Now back to the history. I will go and I will find z for history and z for calculus. Now for history we have, she took 30 minus, what was the average of that class?
25.
25 divided by 5. Now can you give me? So 5 divided by 5 is equal to 1. So z-score of history is equal to 1. Now you can decide in which class she did best, she took best, or she has greater. In calculus, yes, she was the best in calculus. And regarding the two classes in together, I'm going to compare between these two classes together. I can say that she was very good in calculus, and she took 1.5 z-score, and without having a good in history class. Is that clear? Now, for the z-score of each the test that we can state which is highest, the same thing. Maybe we have two different tests. For example, I have two buildings. I want to decide, or I have two projects. I want to decide in which one of them the casting of concrete was best than this one. So I will take for this building alone, and I will take the building alone, and in general I will compare between them. There are two separate. So why to do that? I want to check in average which building has, for example, more strength or more, let me say, concrete strength test and so on. So for this one, I have a table, and for test A, and I have a table for test B. I summarize the table. I summarize the whole table that we have in its x bar and its s. And I will randomly, I will go after that, I will take a sample for this building, and I will take a sample for this building. I want to check whether those two samples were best or how. Now to do that, I have this is the comparison between A and B. So to do that, it's look like the same. I will take the value of A. So how much is the x of A? It was 38. With compared to the table, the whole mean of that A's table, it was only 40. Why 40? Why not 100? Because I'm talking about the z of A. So the z of A I'm going to find the z of A. To find the z of A, I will say, I will use the reading, the x of A, which was 38, and I will go to, this is the 38, and I will extract the x bar of A. The x bar of A, which was 40, divided by the mean of A. How much is the mean of A? It was 5. Now 38 minus 40 is 2. Minus 2 and should be in minus. You have to take care. It was 5 and it's about 0.4 minus. Now for B, I will do the same. I have 94 the x will be minus 100, which was the x bar of b divided by 10. Now we have minus 6 divided by 10, which gives you 0.6 in minus. Now which one is the greatest? This is minus 6,
Yes.
this is minus 4. Now you can say A is having the higher value because both of them are in negative. So A is higher relatively, in relative to the B. This is also called the measurement of position that we have. We have elementary and we have secondary schools. These are data for the elementary. This is for the secondary. These data represent the number of both and secondary school for selected states. So these are their grades. I want to find the mean, median, mode, and mid-range, range, all of them. Then after that, so this could be usual. Find them. So you should find x bar of them and x bar of them. And which set of data is more variable? More variable, it means you have to find let me say, to draw the data and show the skewness. The last thing that we have is the percentile. Percentile is also a measurement of the position of the data. We have a data, we don't know how much is the percentage of the data, let me say less than 50%, or how much is the number of the data, let me say that having capacity, for example, for a specific way. To do that, we have to find the percentile for each one. The number of the data that I want to know, it's below X or below Y, divided by the total number of the all values. For example, so if I want to know, for example, I want to know, for example, I have 1, 5, 10, 20, 50, for example, 9, 25, and so on. So we have 2, 4, 6, 7. These are the number of the data. Now we have 7. Now I want to give me the number, the percentage of the data that I have, of the data, whole data that are less than 10. So how many data that I have, which is less than 10? Now we have 10. So 10 will not be considered. We have 1 less than more than 10, 1, 5, also 9. So we have 3. Number of the data, 3 of the number of the 3 that the data less than 10 is equal to 3. We have only 3 data that they are less than 10. So if I want to show that one in percentage, I will say, okay, 3 out of how much? 7. 3 out of 7 of the data, they are less than, their values are less than 10. If I want to know how much is the percentage of the data, they are less than 100. So all the data are less than 100, right? So I will say the number of the data that are less than 100, we have 7 out of 7, which means 100%. So the 100% it will give you, and why we add in 0.5, sometimes you have in the border, a data in the border, so you should have a 0.5, for example. Now, to do that, so let's say that, okay, the number of the data times the percentage of each one times the 100. Look at the same data we have, 18, 15, 12, 6, 8, 2, 3, 5, 10, 50. So what is the required? We have 18, 15, 12, 6, 8, 2, 3, 5, 20, 10. I want you to tell me how much is the percentage of the data, all the data that we have, they scored less than 12. So I want to know how much is the percentage of data, 12, score 12 or less.
7.
Now, how much is the 12? So the steps for the calculation, it should be look like this. First of all, you have to rearrange. Rearrange means from the lowest to the highest, right? To do that, I will go from what we have. I have 2, 3, 5. So 2, 3, 5, 6, 6, 8,
10,
8, 10,
12,
10, 12,
15,
15,
18,
18,
20.
10. Now, how much is the data they are less than 12? So the number of the data they are less, I have, how much is the less than 12? 6. I have 6. So I will say, okay, the 6% of the data scored 12 or less. I will say that we have 6 out of whole total number is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. So out of 10. Now times 100%, it will give you 60% of the data that are less than 12. Okay? If I want to know how much is the number percentage the data are less than 10, it will be 5 out of what? 12. So this is 5 out of, and so on. If I want to know how much is the data less than 2, it should be 0. Now, how to do that? There is a graph, it's called percentile percentage. I missed to add 0.5, by the way. The number plus 0.5. I'm sorry, plus 0.5 here. So yeah, 0.5, we add 0.5, so 60%, 65%, not 60. That 0.5 for the limit of the border that we have. Okay, so 65% of the class are better than 12. If I want to draw, for example, this data, it could be like this. Class boundaries, and each class boundaries is each cumulative percentage will give you a percentile. So starting with 0, it means that you don't have any data below 89.5%, and in the last one I have the accumulated frequency will give you 100%, and when you want to draw this curve, it will give you the percentile graph. Now, if I want to know how much is the number of the students of, let me say, which are 40% or less, I will go here and I will find its represent, or let me say, the corresponding value to the 40%. If I have 1 to 70, I will go and find the data from this. Lastly, I think we have, if we have another one, decile. Decile is not quartile. Decile, it means that they separate the data. Decile, quartile, we say that we are going to divide the data in 4 quarters. Decile, we are going to distribute the data in 10 parts. 10 deciles. For the first one, D1, I will say this is D1 till D10. So we have D1, D2, D3. So if all the data are ranged in 10 groups, so I can say what I'm going to do is I'm going to divide. I will say this is D1, this is D2, this is D3, this is D4, D5, D6, D7, D8, D9, D10. So I am going to divide the data in 10 equal parts. So this is called decile. So we have a quartile. It means that I'm going to divide the data in 4 quarters. And we have details. How much is the represented data in this part? It's called P1 or P10. It's represented 10%. This is the represented D4. For example, here's D4. This is P20, P30. This is P40, P50, and so on. So for all the data that we have the representing, here's this the percentage, this 60, and so on. So groups of the data will be named as T1 or P10. This is the value of the group in this data. Okay? Now here's the difference between the quartile and decile. So the quartile said you will add, here's the add for 4 groups. This is quartile 1, quartile 2, quartile 3, and quartile 4. Now the data in this range, it will be from 0 to 205%. 50 and 75 and 100%. So this is called P25. 25% of the data, 50% of the data, it means whole, 70%, and this will be P100. This is the difference between these two ones. By the way, the median are here. Here is the median. It will divide the data into 2 parts. It's called P50. Yeah, P50. Last thing that we have in this chapter is to draw. Yeah, first of all, we have these definitions. So, median, lower value, higher value, and I want you to know how to draw. So Q1, Q2, Q3, I want them to draw a box which is called drop box. All these are mentioned before. To draw a drop box, a box plot. Box plot is another graph. Here's another graph. When you have a data, you want to draw the data distribution for what you have. You have to have at least, here's the 5 data we have. We have Q1, Q2, Q3. All the data, if you have data, you should find for this data these 3 values. Q1, Q2, which is the midterm, and the Q3. And we have to have the lower value of the data and the highest value of the data, then show to the people that here's the data that we have. Here's the data, and this will represent the data. For example, this is called a box plot. This is a box plot. The box plot will be 2 points, so the lower the higher, and then we have kind of distribution. We have the data 89, 47, 164, 296, 13, 215, 138, 86, 78, 48, and 39. I want to show this instead of this data. I want to show them a box plot to represent represent this one. To do that, I should first find those 5 points. 5 points which are so we say that we have 89, 47, 164, 296, and 30, and 215, and 138, 78, 48, and lastly 39. So we should to draw a box plot. We should need Q1, Q2, Q3. Means midterm Q2, by the way, is the median, and lowest and the highest. These values should be found from the data. First of all, we have to find the Q1 and Q2, Q3. To do that, I will rearrange the data from the lowest to the highest. To do that, I will start with the lowest one, which is, we have how much? 48, 47, right? 47.
For which ones?
59.
Yeah, 39, sorry.
30.
We have 30.
We have 30 also.
Yeah, but so we have to start 30 and 39 and
74, 78.
No, 48
47,
and 48.
47, now 47, yes,
48.
So 47, 48,
78. 78.
78,
89.
89, okay,
138.
138,
164.
164,
215.
296,
No, we have 215.
215, yes sir, 215, and
296.
296. Now you can see how much is the highest value. The highest value,
296.
296. How much is the lowest value? 30. Now remain, we need the other Q's, Q1 and Q2. For this one, how many data we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10 should be divided in 2 parts. 1, 2, 3, 4, 5. This is 2 parts. This is 2 parts. Right? 1, 2, 3, 4, 5. So the median is the average. The median, or its part 2, is equal to how much? It will be equal to 78 plus 89 divided by 2.
83.5.
83.5. Now, I want to know the Q1. Where's the Q1? I will divide this 5 into 2 parts. So here is the 2 parts. So the median is 47, or Q1, because it's odd number. So Q1 is equal to 47. And the Q3 now is equal to 1, 2, 3, 4, 5. So here's the Q3. Q3 is equal to 164. Now I have to draw the box. The box should be aligned, and here's the box. And first of all, you have to be aware that you are going to scale this. So the scale, we have 0, the first one, the highest one, it was 30 years. We have how much? 296. 6. So the high and the low, 13 and 12. And you have to Q1, Q2, Q3. Q1 is 47, Q2 is 83.5, and then we have 164, and this is called the box or the dog box plot of this level. Okay? Yeah. Okay. So we are going to now
Next question.
Bırakalım.
Türkçe geçti.